Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, faculty members across India. Initially started by myself in 2017, and we used to conduct several online programs to help the students. As a part of the online problem solving session series, today we have a session on group theory, and we blessed to have Miss Ardra with us to handle the session. Miss Ardra studied her MSc from Calicut University, Kerala, and she is currently pursuing PhD at University of Hyderabad. She qualified CSER NET JRF June 2024 with All India rank 17. So I am sure that her experience in this type of competitive examinations will be really helpful in helping you to achieve good ranks in the forthcoming examination. In today's session, we will more concentrate on IIT JAM questions, but that will be certainly useful for those who are preparing for other exams as well. So I would like to express my gratitude and thanks to Ms. Ardra for accepting our invitation and joining with us. I welcome everyone to this program. Welcome, Ardra.
Thank you, sir. First of all, I would like to thank you, Vinod, sir, for giving me this opportunity. I used to be in the audience, getting inspired from the research scholars and other resource persons. Now I am happy that I am one among them. Thank you, sir, for this moment. Today, in this session, I have taken some topics of group theory, which are very important for various competitive exams like IIT JAM, CSIR NET, GATE exams and all. Here I have listed some topics like abelian and non-abelian groups. From this, they will be given some group. They will specify some properties, and with that property, we have to guess which group it is, and we have to guess other properties of groups. And in case of cyclic groups, we know that finite cyclic groups are isomorphic to Zn. And so they will be asking about the properties of Zn. And then permutation group, it is very, very important in especially for the IIT JAM examination. If I have analyzed the past 5 question papers. In all that question papers, at least one question was there from permutation groups. So if we analyze the elements of permutation groups, and if we are clear about how the elements of the Sn look like, then we can solve that questions easily. So in this session, we will be discussing the questions from that concept also, and then Lagrange's theorem for finite groups, normal subgroups, quotient groups, homomorphism. That is also very, very important for all exams like IIT JAM, CSIR NET, and GATE exams. Also, homomorphisms are very, very important. And then silo theorems and class equations are not there in the syllabus of IIT JAM, but they are important for CSIR NET and GATE exams. So in this session, I am focusing on IIT JAM, but it will be very helpful for other aspirants also, CSIR NET and GATE aspirants, as they can just clear their basics. I think so. So in group theory, there are many concepts and there are many results related to that. So explaining each and every concept and results will be time taking. So what I have planned in this session is, I have taken questions from previous year question papers of IIT JAM, CSIR NET, GATE exams. So we will be discussing the question, solution, and I will discuss the concepts related to that question. So it will be like recalling the concepts and thus a revision. Because you have exams in 2 to 3 weeks, explaining each and every concepts will not be efficient. I feel so. So let us begin the session. So let us begin with some simple questions. First question I have taken from IIT JAM 2023. Let G be a finite group, then G is necessarily a cyclic group if the order of G is. So this is a simple question. You can answer immediately, I think.
7.
Yes.
7.
7. Very good. So here we have a well-known result that every group of prime power order is cyclic. We can also discuss other options also. Why not option A? Why not option C? And why not option D? Why not option A? Can you give a counter example?
K4.
K4, Klein 4 group. Yes. Good. Then option C?
S3.
Yes, S3. What about option D?
D5.
D5.
Yes. Yes, D5. Yes. So let me explain the. Let us discuss the other groups also. Means other non-isomorphic groups of order 1 to 10 also. Let us discuss. So here we have a fundamental theorem of finitely generated abelian group. It says that every finitely generated abelian group G is isomorphic to a direct product of cyclic groups. So using that we can just know which all non-isomorphic groups are there of order 1 to 10. So if you are taking order 1, then only one group will be there. It will be isomorphic to singleton identity, and it will be abelian, and there is no non-abelian group. If you are taking order 2, then we know that every group of prime order is cyclic. So it will be isomorphic to set 2 and no non-abelian group. And if you are taking 3, then also only set 3 will be there. If you are taking 4, then what happens? Then we have every group of order p square is abelian. And we have the fundamental theorem which says that every finitely generated abelian group is isomorphic to a direct product of cyclic groups. So either a group of order 4 is either set 4 or it will be set 2. Sorry, it is not set 2 cross set 2. It is set 2 cross set 2. This is wrong. Sorry for the mistake. Set 2 cross set 2, that is Klein 4 group. And there will be no non-abelian group. Okay, and if you are taking a group of order 5, then it will be isomorphic to set 5 and there will be no non-abelian groups. And if you are taking order 6, that means 2 into 3. So we have a result. If G is a group of order PQ, where P and Q are distinct primes, such that if P divides Q minus 1, then G is abelian and cyclic. But if P doesn't divide Q minus 1, then G is abelian and cyclic. But if P divides Q minus 1, then there are exactly two non-isomorphic groups of order PQ. One is abelian and the other is non-abelian. If in particular, if PQ is even, then group of order PQ is either set PQ or dPQ by 2. That means if the G is of order PQ and if P divides Q minus 1, in this case, if we are taking N is equal to 6, then it is 2 into 3 and 2 divides 3 minus 1. So in that case, there are two non-isomorphic groups. There are exactly two non-isomorphic groups. One is abelian and other is non-abelian. So since PQ is even, we will get that either it is isomorphic to set PQ or it will be isomorphic to D3. So these are some results that we can recall. So using that result, we will get that the groups of order 6 are either set 6, which is abelian, and S3, which is non-abelian. Now, if we are taking order 7, then we have we will get that it will be isomorphic to set 7. If you are taking order 8, then there are five groups. Either it will be in case of abelian, it will be isomorphic to either set 8, set 4 cross set 2, or set 2 cross set 2 cross set 2. In case of non-abelian, there are two groups of order 8, Q8, quaternion group, and D4. Okay. And if you are taking order 9 means it is a group of order P square. So we will get it will be abelian and Z9 and Z3 cross Z3 are the only possible groups. If we are taking 10, then we are using the same results of here. Here we are getting 10, 2 into 5 and 2 divides 5 minus 1. So there are exactly two non-isomorphic groups of order PQ. And since PQ is even, we will get that it is either isomorphic to Z10 or it is isomorphic to D5. So here are some listing. And if you are taking order 11, then it will be then only one group is there, it will be isomorphic to set 12. Okay, and now what about from this result, what about how many groups will be there of order 50?
1.
1. Because here we are using this, it is an order of PQ, and here PQ is 3 into 5, and 3 doesn't divides 5 minus 1. So obviously it will be abelian and cyclic, and hence it will be isomorphic to set 50. So such questions they can ask. Okay, maybe they have given some large values, but it will be the product of P and Q such that P doesn't divide Q minus 1. So it will be isomorphic to set PQ. So they are just asking the properties of set PQ. So you can just note it down these results. Okay, let us go to the next question.
Ma'am, which one is P, which one is Q, ma'am? 3 or 5?
P will be the smallest.
Okay, ma'am. Thank you.
Smallest prep. Okay. So let us go to the next question. It is taken from IIT JAM 2022. The number of distinct subgroups of set 999. You can try. Here answer is visible, I think, but you can try yourself. You're posting in. Okay, I can see the comment box. Yes.
It's 8, ma'am.
Yes, very good. Yes. So this is a question related to the property of cyclic group, finite cyclic group, or we can say Zn. Let us recall some results related to this. We all know that what is Zn. Zn is just the set of all. The set will be 0, 1, 2, etc. n minus 1, and the operation is addition modulo n. Here we have a result that number of subgroups of Zn plus n is tau n. Tau is the number of positive divisors of n. So if we are taking n is equal to 999, we can write it as 3 cube into 37. And we are applying the tau function. Tau function, we have a formula. Tau of 999 is equal to, here it is 3, so 3 plus 1 into here it is 1, so 1 plus 1, that is 4 into 2, that is equal to 8. Hence the answer is 8. I hope that the solution is clear. Can we go to the next question?
Ma'am, please
Yes, ma'am.
explain tau of 999 equal to how it comes 4 and 2.
Okay, here we have 3 cube. 3 cube into 37 power 1. So we are taking 3 plus 1. Here the power is there, no? 3 plus 1 into 37 raised to 1, it is 1 into 1. That means if we are taking, suppose it is P raised to alpha, P1 raised to alpha 1 into P2 raised to alpha 2. Then tau of P1 raised to alpha 1 into P2 raised to alpha 2 is equal to alpha 1 plus 1 into alpha 2 plus 1.
Thank you, ma'am. Thank you.
Okay. So can we go to next question?
Yes, ma'am.
Okay. So this is also a question related to the property of cyclic group. How many elements of the group set 50 has order 10? This is taken from IIT JAM 2021. I have focused on IIT JAM questions. This will be helpful for other aspirants also.
4.
4. How? Which concept you used? Means which property?
Either 5 function, ma'am.
5
Okay.
function.
Good. So let me begin the explanation. We can recall the results. I know you people know the results, but we can just recall. The number of elements of order m, where m divides n in Zn plus n is given by phi of m. Phi is the Euler phi function. So here we have, we need to find the elements of order 10. So we are considering phi of 10, that is equal to phi of 2 into 5. So we can write it as phi of 2 into phi of 5. So phi of 2 is 1 and phi of 5 is 4. So 1 into 4 is equal to 4. Option B is correct. So let us move to the next question. This is a question from IIT JAM 2022. You can try. I will give like 2 minutes like that.
Is it option B?
Option B. Okay, let us see.
Option B, B.
B. Okay. Yes. Option B.
Yes, ma'am. Option B.
Yes. Option B. Okay. Any other? Okay. How you got option B?
H union K is a subset if and only if one is contained in another. So
Yes. H union K is a subgroup. Okay. So let me start explaining. So yes, he has said that for subgroup H and K of group G, H union K is a subgroup of G if and only if H is either contained in K or K is contained in H. So here we have H is of order 337 and K is of order 674. So H union K is a subgroup means either H is contained in K or K is contained in H. So here the possibility is H is contained in K. H is contained in K, and so H union K will be
K.
K. So what is the order of K? Sorry, what is the order of H union K?
674.
Yes, 674. So we can so option C will be correct and option B will be wrong. What about other options? Option A, D.
first is correct because its index is 2 in
Index is 2. Yes, ma'am.
Yes, very good, very good. Yes, index is 2, so it is a normal subgroup. What about option D?
Option
Option D also correct because H union K is a K and
Yes.
the normal subgroup all मतलब जो K है वो trivial normal subgroup हो गया उसका.
Yes, K is a normal subgroup of K. That is true. Okay. So here it is a means what part B question in case of CSIR, or we can say it is an MCQ question. Only one answer is correct. So in this case, in attempting such questions, either you can go for elimination methods, like you can discard all other options and conclude one option is right. Okay, that option also works. Means that method also works in case of MCQ questions. Okay, let us. Huh?
Can you explain the first option?
First option. Okay. Here we got that H union K is equal to K. You got that right? H union K is equal to K. Okay, so what is the cardinality of H? It is 337. And what is the cardinality of H union K? Cardinality of H union K is nothing, just cardinality of K. That is equal to 674. Okay.
Yes.
So what is the index of H in H union K? How we will calculate index of H? It is just H union K means cardinality of H union K divided by cardinality of H. That is equal to 674 by 337. That is equal to 2. That means index of H is 2 in H union K. And always the index, if it is index of 2, then it will be a normal subgroup. We have that result.
Okay, ma'am.
Okay. So let us move to the Next question. This is a question from IIT JAM 2020. Suppose that G is a group of order 57, which is not cyclic. If G contains a unique subgroup H of order 19, then for any G not in H, order of G is. Okay, some have answered option 3. Sorry, not option. The answer is 3 like that. Okay, good. Let me wait for 1 minute also if somebody is trying. Yes, Ankit
3.
has mentioned that it is using Lagrange's concept. Yes. Okay, so let me start explaining. So here, let us recall the result of Lagrange's theorem. The order of any subgroup of a finite group divides the order of the group, and also it says that order of the element of the group divides the order of the group. Okay. So here it is given that the group is of order 57. Group is of order 57, that is equal to 3 into 19. So what are the possible order for elements of G?
1,
Using
57.
1, 3.
19 and 57.
Yes, 1, 3, 19 and 57. So these are the possibility. So we can discard 1, isn't it? Because only the identity element will contains order 1, and this identity element is there in the subgroup H. So this one possibility is cancelled, and we can cancel this 57 possibility, the order 57 also. Why can we discard this 57?
Because
Not
G is
Non-cyclic.
non-cyclic.
Yes, good. If it has an element of order 57, then it's generated, and hence it will be a cyclic. But it is given here that it is not cyclic, and hence this 57 is not possible. So the other possibilities are 3 and 19. What about 19? Can we have? Why this 19 is discarded?
Because G does not belong to H.
Yes. If any order, if the G, if order of that G is 19, then that G will form another subgroup which will be distinct from H. But it has already given that G contains a unique subgroup of order 90. And hence this 19 possibility is also not there. And hence 3 is the answer. I hope that the answer is clear. If anybody have doubt, you can ask.
Can you explain
Which one? Again explain.
why not 19?
Okay, why not 19? Because suppose this G has order 19. Then the subgroup generated by this G will also will have cardinality 19, isn't it? If G has order 19, then this subgroup generated by G and the subgroup H will be distinct.
Yes, Ramay. I got it.
Okay.
Ma'am, is it possible to give explanation with writing, ma'am?
with writing this explanation?
It's small hints like that.
Small things. Actually, I don't have any system of typing system, means any pen and all. That's why I have just typed all the answers. If you want, I will give to Vinod sir.
Don't want, ma'am. Okay, ma'am. Thank you very much.
If you want, I will share with Vinod sir and then. Okay. Okay, can I go to the next question?
Yes, ma'am.
Okay. So this is a question from IIT JAM 2024, the recent question paper. So here, let G be a finite group containing a non-identity element which is conjugate to its inverse. Then which one of the following is true? So you can take time and I will give 2 minutes time. Okay, option C and D can be discarded by K4. Yes. Yes. Why not option B? Using Lagrange's theorem. Yes. Any other answers from other students? Dihedral group DN. Using that, you are trying to discard option C and D, or okay. So let me start explaining the solution. So here we have given a finite group containing a non-identity element which is conjugate to its inverse. Then which one of the following is true? So here four options are the order of G is necessarily even, it is not necessarily even, it is necessarily cyclic, or it is necessarily abelian but need not be cyclic. So first of all, let us see which all option we can discard. So here Ankit has mentioned that we can discard it by taking set 2. Here I have written again one mistake happened, set 2 cross set 2. It is not like this, set 2 cross set 2. So by taking set 2 cross set 2 or the claim for group, we can discard option C and D. Why? Which element is there which is conjugate to inverse? Can you say? Which is that non-identity element in set 2 cross set 2, which is conjugate to its inverse?
Zero one.
Yes, 0, 1. Good. So by taking that, we can discard option C and D. Then why option A is correct. Why not option B? So here we have a result that a group of odd order has no non-identity elements which are conjugate to their inverse. So let us let me give a small proof for that. So from here we have given that there is a non-identity element which is conjugate to its inverse. So I am taking, let A be that element. So A not equal to E belongs to G, B conjugates to its inverse. What is meant by conjugate to its inverse? That means there exists a G belongs to G such that A is equal to G inverse A inverse G. So there are two cases. Either case one is that A is equal to A inverse, or case two is that A is not equal to A inverse. If A is equal to A inverse, then we will get that A square is equal to identity, so that order of A is even. So as you have mentioned, using the Lagrange theorem. What is the Lagrange theorem? It states that order of the element should divide the order of the group. So here we got that order of an element is even. So the order of the group must be even. So in the case 1, we got that order of the group must be even. So what about the case 2? If A is not equal to A inverse, then we are taking, let B belongs to in conjugate class of A. That means there exists H belongs to G such that B is equal to H inverse AH. So then we are taking inverse, B inverse equal to H inverse A inverse H. And we are substituting A inverse. We are substituting here. So we will get H inverse GA, G inverse H. So this implies that what we got now, B inverse is equal to H inverse G, A into G inverse H. That means B inverse belongs to conjugate class of A. That means if you are taking B, then if B inverse is also there in the conjugate class of A. So this implies that conjugate class will have pair of elements, or otherwise the order of conjugate class of A must be even. And again we have a result that conjugate class, the order of the conjugate class divides the order of the group. We can use the Lagrange concept. We will get that order of conjugate class divides order of the group, and hence order of the group must be even. And hence option A is correct. Is it clear for you? Do you have any doubt?
Ma'am, how is option D discarded using Z2 cross Z2?
Okay. If you are G is necessarily abelian but need not be cyclic. Okay. If we are taking Z2 cross, sorry, by Z2 cross Z2, I think we can't discard option. Okay, Z2 by Z2, we can't discard option D, I think, but we can take. What about if we are taking D4? What about D4? If you are taking D4, then we are. Then we can discard no option D. If you are taking D, yes, there is an element of order. Means if you are taking the reflection, not reflection, means half rotations, there is an element which belongs to the center. So order 2 element will be there. So D4, sorry, here we can take D4 to discard option D. Is it okay?
Yes, ma'am.
Okay. Any other doubts?
No, ma'am. Continue.
Okay. So let us go to the next question. So this is a question from IIT JAM 2023. Here they have given two statements. We have to check whether they are true or false. So first statement is that every infinite group has infinitely many subgroups, and the second statement is that there are only finitely many non-isomorphic groups of a given finite order. So try it.
Both are true, ma'am.
Both are true. Okay. Why option 1 is true? Can you give a small explanation?
Ma'am, there are two possibilities. Either it
Ah.
could be a cyclic infinite group or it could be non-cyclic.
Okay.
If it is cyclic, then it is
Huh.
isomorphic to Z, and then
Yes.
Z has infinitely many subgroups.
Yes.
If it is not cyclic, then we can have all the subgroups generated by the elements, and then
Okay.
again there will be infinitely many subgroups.
Yes. Good. What about second option? Second statement? Did you use any famous result or? Okay, anyway, both the statements are true. So let me start explaining. As he has said, if it is an infinite cyclic group, then it will be isomorphic to set of all integers. And we know that there are infinitely many subgroups. And if it is not that, then also we can take, if we are taking elements, each elements, and taking the subgroup generated by that, then also we will get infinitely many subgroups. So the statement one, if we are taking element from G, then take the subgroup generated by that element, so we will get that it is a subgroup of G. So there are infinitely many subgroup, and hence statement one is true. For statement two, we have a famous theorem, Cayley theorem. Cayley theorem states that every group is isomorphic to a group of permutation. Okay, so it is a group of permutation, or we can say that this is a subset of what we will say Sn. It is isomorphic to a subgroup of Sn, like that. So every group is isomorphic to a group of permutations. And we know that then there are only finitely non-isomorphic groups, isn't it? So statement 2 is also true, and hence option A is correct. So for the statement 2, we will get an intuition that yes, it is true, but through this Cayley theorem, we can confirm that. Any doubts? Sorry. Any doubts? Can I move to the next question?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So this is a question from IIT JAM 2024. It's a recent question. Let G be a group of order 39 such that it has exactly one subgroup of order 3 and exactly one subgroup of order 13. Then which one of the following statement is true? G is necessarily cyclic, G is abelian but need not be cyclic, G need not be abelian, G has 13 elements of order 30. You can try. Option A. Many have answered option A. Yes, option E is correct. If somebody is trying, you can try. Yes, subgroup of order 3 and 13 are both normal. Okay, so let me start explaining the solution. So here we have given a group of order 39 such that it has exactly one subgroup of order 3 and exactly one subgroup of order 13. Then which one of the following is true? That is asking. So here, so let us first analyze the option D. Okay, so first let us analyze the option D. Option D, it is saying G has 13 elements of order 30. This is not true, isn't it? Why? Because there are exactly one subgroup of order 13. So in that there are exactly one subgroup of order 13 means there are 13 elements in that subgroup, but one element will be identity. So 13 minus 1, that is 12 elements will be there of order 13. Hence we can eliminate option D, isn't it? Is it clear?
Yes, ma'am.
Okay. Then what about the other options? Here H3 and H3. Here I have denoted H3 for the subgroup of order 3 and H13 for the subgroup of order 13. So H3 and H13 are unique. It is given in the question. So if it is unique, then it will be normal in G. And therefore, HK is a subgroup of G. HK is the product of subgroups. HK is a subgroup of G. And the cardinality of HK, we have a formula that cardinality of HK is equal to cardinality of H into cardinality of K divided by cardinality of H intersection K. Okay, so cardinality of H is, here it is 3. Means here I have taken cardinality of, if we are taking cardinality of H3. H3 is 3 and H13 it is 13 and H intersection 3. H3 intersection H13. What it will be? It will be just identity only. So the cardinality is 1 and hence H3 into H13 it will be G only. So we have a result if let G be a group containing normal subgroups H and K such that H intersection K is equal to identity and H join K. H join K means the smallest subgroup of G containing H and HK. Smallest subgroup of G containing HK. If it is G, then G is isomorphic to H direct product K. So here we got that H3 intersection H13 is equal to identity and both are normal subgroups, and H3 join H13 is equal to G. So that G must be isomorphic to H3 cross H13. H3 means it is just the cyclic group of order 3. So it will be isomorphic to set 3. And H13 is a cyclic group of order 13. So it will be isomorphic to set 13. So set 3 cross set 13, that is isomorphic to set 39. And hence, we got that G is isomorphic to set 39. So let us analyze the option. G is necessarily cyclic. Yes, that is true. Option B is that G is abelian but not need not be cyclic. That is not true. C need not be abelian. That is not true. And option D already we have discarded. And hence, option A is correct.
Ma'am, why G need not be abelian?
Here we got that then if according to these conditions, no, we got that then G must be isomorphic to set 39. There are no other possibilities of G.
Okay, ma'am, if I take 39 is equal to product of 3 and 13. So these are 2 primes, 3 and 13 are primes.
Yes.
So 3 divides, okay, yes ma'am, 3 divides 13 minus 1, okay, yes ma'am.
Yes, so there are 2 possibilities are there, but here we have a condition on G that it has exactly one subgroup of order 3 and one subgroup of order 13.
Okay, ma'am.
So from that we are concluding that it is, yes, okay, from that we are concluding that it is isomorphic to set 39, and thus we are getting these properties. Any doubts?
Ma'am?
Huh?
I actually solved this in a little different way. Could you see if it's correct?
Okay. Where is it?
Our group has order 39. That is, it has 39 elements. So whatever element we take, it will either have order 1, 3, 13 or 39.
Yes.
Now we have exactly one subgroup of order 3 and of order 13.
Okay.
Say that I have one element of order 1. That is the identity element.
Yes.
And the order 3 subgroup is unique. I'll have 2 elements of order 3.
Okay, yes.
And elements of order 13.
Okay.
2 elements left of the 39 elements. So these elements should surely have order 39, right?
Yes.
So this implies that this group is cyclic because I have elements of order 39.
Yes.
Is that accurate, ma'am?
That is also good. A good way. Good analysis.
Okay. Thank you, ma'am.
Okay. Yes, we can use the concept of elements of groups also to analyze the questions. Okay. So can we move to the next question?
Yes, ma'am.
Okay. So this is a question from CSA at June 2023. So this is also asking they have given some group of order and we have to guess other properties of this G, whether we have to check it is abelian, cyclic, simple or non-simple, like that questions. I hope that you know the definition of symbol group. Symbol group means symbol group. Anyone? Definition of symbol group?
If
Trivial
it has
It has only trivial normal sub.
if G has no proper normal subgroup, then G is simple.
Yes. Okay. So you can try this question also. Okay, so let me start explaining the solution. So here we have the group of order 2023. So 2023 we can write it as 7 into 17 square. Okay. Now we have a result that let G be a group of order PQ square where P comma Q are distinct primes. If P doesn't divide Q square minus 1, then G is abelian. We have a result. We can prove it using the Silo theorems and all. If you want, you can refer some books like Fraile, Contemporary Abstract Algebra by Gallian and all. I have given in the reference books. So you can refer that and you can go through the proofs. But now I am not explaining the proof. If G is a group of order PQ square, you just note this result. If G is a group of order PQ square where PQ are distinct primes, if P doesn't divide Q square minus 1, then G is abelian. Okay, so we will get that it is abelian. So option 1 is correct. Here it is an MSQ question. In case of MCQ questions, we can use elimination method and we can conclude one question. Sometimes we can do like that. But in case of MSQ questions or in case of MSQ questions, we have to analyze each options. Okay, so first option it is G is abelian group. So this one is correct. So what about second? Second, it is a question mark. And if it is an abelian group of order 2023, then we can conclude that it is not a symbol group because it will have non-trivial normal subgroups. So we can conclude that G is not a symbol group. So 1 and 4 are correct. 3 is not correct. Is it clear? Any doubts?
No, ma'am.
Okay. So yes, if you have doubt, you can ask.
Discuss about the 3, 4 option, ma'am. Simple proof.
Okay. Here we are getting that from this result we are getting that G is abelian group of order 2023. So abelian group of order 2023 will be looking like either it will be cyclic group like set 2023 or it will be isomorphic to set 7 cross set 17 cross set 17. So in either case means if it is an abelian group of order 2023, obviously it will have all the subgroups of abelian groups are normal and hence it will not be simple. The only abelian only abelian groups which are symbol will be of prime order, right?
Got it.
Okay. So we got we can discard 3 and option 4 is correct. And option 2 can be discarded because we can take, if we are taking here also I had in the typing mistake. Sorry, I couldn't hear.
Option B can be eliminated by the option. Example, the Z7 divided by Z17 square.
Yes. Set 7 cross set 7 17 cross set 17. Again here a mistake happens while typing. It is like set 7 cross set 17 cross set 17. So by taking that group we can discard option 2 also. So option 2, option 3 is eliminated. Option 1 and 4 are correct. So whenever we are doing MSQ questions, be careful about each and every option. Because if you are taking CSIR net exam part C, it is 4.7 marks, 4.75 marks are there. So if you got one question correct, then it will your marks will be increased and your rank can also be increased. So but if you choose a wrong option, then you are losing at 4.7 marks. So be careful while attempting part C questions like MSQ questions. Each and every option you should analyze and you should be very much clear. If you are taking one option like this, try for all the results. Like, can we conclude that? Can we confirm that it is true or it is not true? Okay. So suppose if options are like some statements, suppose you are not able to discard that statement, then try to prove that. Maybe some by simple methods you can try to prove some statements. Here, not I am saying here, I am saying some, suppose in part C and all, if you are getting some statements, if you are taking any groups or any examples, we can't discard that option. But maybe we can prove that statement also, some simple ways. So be careful about these MSQ questions. Okay, so let us move to the next question. Question 10. These questions are from the permutation group concept. So here I have already mentioned that the questions, if we are very much clear about the elements of the permutation group, then we can solve that question easily. So especially for IIT jams and all, at least one question is there from permutation group also. So it is very important to understand the elements of the permutation group, SN and SN. So here is a question from IIT JAM 2022. The number of elements of order 12 in the symmetric group S7 is equal to. You can try for, I will give you some time. You can try that and I will explain also. Okay. So here we have to find the number of elements of order 12 in S7. So let us recall some results, what all we need for solving this question. First is that order of a permutation. What is meant by order of a permutation? Order of a permutation expressed as a product of disjoint cycles is the least common multiple of the length of the cycle. That means let us take the permutation here. 1, 2, 3, 4, 5. So what will be the order of the permutation? 1, 2, 3, 4, 5.
6.
Yes, 6. So likewise, we should be very much clear that it should be disjoint cycles. It's the product of disjoint cycles. If you are taking 1, 2, 3 and then 3, 4, then we can't take LCM. First, it should be the product of disjoint cycles. Then only we should take the LCM. Okay, so this is the one concept where we have to know what is meant by the order of a permutation. The another concept is that when two permutations are similar. Two permutations are similar if they have same cycle decomposition. For example, let us take 1, 2, 3, 4, 5 and 2, 3, 4, 1, 5. So here we have 1 3 cycle and 1-2 cycle. Here also we have 1-3 cycle, 1-2 cycle. So these have same cyclic decomposition. But if you are taking 1, 2, 3, 4, 5 and here 1, 2, 3, 4, 5, then this is 1-3 cycle, 1-2 cycle, and this is 1-5 cycle. So this have different cycle decompositions. So just know this concept. Then now we need to analyze S7. We have to get the number of elements of order 12. So what we have to do? First, we have to find the partitions of N. Here, since we are focusing on S7, let us take the possible partitions of S7. 7, 6 plus 1, 5 plus 2. I know that many students know, but for the students who don't know, that's why I am explaining this. 7, 6 plus 1, 5 plus 2, 5 plus 1 plus 1, 4 plus 3. These are the possible partitions of 7. So here all the possible partitions of 7 has given. Now let us analyze what will be the order of each structure. If we are taking 7, then obviously the what we will say, the order will be 7. If we are taking the permutation of the structure 6 plus 1, then it is LCM of 6, 1, it is 6. Here if we are taking 5 plus 2 structure, what will be the order?
10.
Yes, 10. So if we are taking 5 plus 1 plus 1, then also we will get 5, 4 plus 3, 12, 4 plus 2 plus 1, then we will be getting 4. This structure, the permutation of this structure will have order 4 and so on. So the from here what we need, we need the elements of order 12. So we have to pick up the structure which have order 12. So from here which structure will have order 12?
4 plus 3.
Yes, 4 plus 3. Only 4 plus 3 will have this possibility. So we have to analyze the structures of 4 plus 3, or we have to find the number of elements in S7 which are of this structure 4 plus 3. 4 plus 3 structure will look like this 1, 2, 3, 4, 5, 6, 7, or like 1, 3, 6, 7, 2, 4, 5. So we have to analyze that. For that, one more result we need to know. Let sigma belongs to Sn has cycle decomposition n1, n2, etc. nk, and let alpha I denotes the number of cycles of length I in n1, n2, etc. nk such that summation alpha I is equal to n. Then the number of elements similar to sigma equals n factorial by 1 power alpha 1, 2 power alpha 2, etc. We can discuss this through examples. So this is a result we need to know. So here, coming to this question, we need the permutations of the structure 4 plus 3. So 4 plus 3 means what? 1 3 cycle and 1 4 cycles. 1 4 cycle. Okay. So here, what about this N1? N1 means the cycles of length N1. N2 means cycles of length 2. Like that. So here, alpha 1 means number of cycles of length 1. Sorry. Alpha 1 means the number of cycles of length 1. Here we don't have any cycle of length 1, so it will be 0. Alpha 2 will be 0. Alpha 5, 6, 7 will be 0. But alpha 3 is 1 and alpha 4 is also 1 because we need 1 3 cycle and 1 4 cycle. Okay. I hope that you got it.
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
Okay, good. So now we are applying that formula. The number of elements of order 12, that is equal to here number of elements similar to sigma, and also this is equal to n factorial. What is n factorial? It is 7 factorial divided by 1 power alpha 1 is 0, 2 power 0, 3 power 1, 4 power 1, 5 power 0, 6 power 0, 7 power 0, and 0 factorial, like that we are writing. And then 7 factorial divided by 3 into 4, and hence we will get it is 420. Is it clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. If anybody have doubt, you can ask. I hope that nobody have any doubt. So let us recall what we have done. First of all, we have find the partitions of n, and we have pick up the points, pick up the structures that we need. Like if we want order 12 elements, then we are picking the permutations which have order 12, and then we are finding the number of that structure using this formula. So using the same concept, let us do this question also. It is from a recent paper, IIT JAM 2024. Which one of the following is true for symmetry group S13? This is just using the concept. We don't need the other formula. We just need the concept of order of the permutation. S13. Okay. A.
Option A,
Oh,
ma'am. Yes, sir. 43.
option A. Okay. So option A is correct. Any others have different options, different answers? Okay, so let me just explain how is this. Means we have already discussed in the previous question that order of a permutation, which is expressed as disjoint product of cycles, is just the LCM of that. So here we have to find S13. S13 here we have. So S13, if we are finding the partitions of S13, we are checking whether we have any element of order 42 like that. How can we write 42? Means how will that structure
7
look?
plus 6.
Yes, 7 plus
6.
Yes, good. So 7 plus 6. So if we are taking this permutation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, then this permutation will have like LCM of 7, 6, it will have order 42. So option A is true. What about option B?
It is an element of order 35. 7
Yes.
plus 5.
Yes, good. 7 plus 5. If you are taking 7 plus 5 plus 1, then like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. If we are taking like this, then we are getting an element of order 35. But the option is that it is there has no element. Since this is an means MCQ question, if we get option A, then we are done. Suppose it is an MSQ question, and suppose you read it wrongly, like S13 has elements of order 35, then your marks will be gone. So be careful, especially while attending the MSQ questions. Okay, so what about option C? S13 has an element of order 27.
No, ma'am.
No, it's not possible. We can't split 27 in such a way that, sorry, we can't split 13 in such a way that its order is 27. And what about option D?
S13 has element of order 16. Cyclic decomposition 1, 3, 4, 5.
1, 3, 4, 5. Correct. Okay, good. So option, if you are taking 5 plus 4 plus 3 plus 1, splitting like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This element will have order 16, and hence option D is also true, because it is saying that it doesn't has an element of order 16, and hence option A is correct. I hope that the answer is correct. Can we move to the next question?
Yes, ma'am.
So here we have to find the number of elements of order 2 in S4. You can try it. I will give like 3 minutes. 3 minutes time. You can try it using the same concept that we have used in the previous. The number of elements of order 2 in S4.
Ma'am, previous question 9 plus 3 plus 1 we can able to write now, ma'am.
Which one? Previous question. Okay. Which?
Option C, ma'am.
Okay. You say?
9 plus 3 plus 1.
If we are taking 9, what will be the LCM then?
9.
But we need
Sorry,
LCM.
ma'am. Sorry, ma'am.
Okay, it's okay. Okay. Some have given answer 9. Yes, 9 is the answer. Let us wait for others also. Okay, so let me start explaining. So here we need elements of order 2 in S4. So first we find the partitions of 4, like 4, 3 plus 1, 2 plus 2, 2 plus 1 plus 1, 1 plus 1 plus 1 plus 1 plus 1. Sorry, here it is wrong. 1 plus 1 plus 1 only. Here 1 is extra. So, and hence in the first structure, it will have LCM. It means LCM will be 4. Here it will be 3. This structure will have order 2, and this will also have order 2. This will have order 1. So we need elements of order 2. So which all structures we have to pick? 2 plus 2 and 2 plus 1 plus 1. And the number of permutation in S4 of structure 2 plus 2 is, we have to like 4 factorial divided by, there are 2 cycles of length 2. So 2 square into 2 factorial. And hence we will get 24 by 8. It is equal to 3. And the number of permutations of structure 2 plus 1 plus 1. Here it will be like there is one cycle. There are 2 cycles of length 1. So 1 power 2. And 1 cycle of length 2, so 2 power 1, and into 2 factorial. So it will be 24 by 4, that is equal to 6. And we have to, when we are finding the total, we will get 3 plus 6 equal to, there are 9 elements in S4 of order 2. I hope that you got that answer. If you have any doubt, you can ask. Otherwise, we can move to the next question. Okay, so let us move to the next question. This is also a similar question. So you just say what all structures we have to take. The number of permutation in S4 that have exactly 2 cycles in their cycle decomposition. This is a question from IIT JAM 2023. You just say which all structures we have to take, which all partitions of 4 we have to consider.
2 plus 2 and 3 plus 1.
Okay, 2 plus 2 and 3 plus 1. Why not 2 plus 1 plus 1?
Because it has 3 cycles.
Yes, it has 3 cycles. Okay, so we have to consider only 3 plus 1 and 2 plus 2. So the number of permutation in S4 of structure 2 plus 2 that we have already done in the previous question, it is 3. And in S4 of structure 3 plus 1, it is 8, and hence total 11 will be there. You can try. You can take the screenshot and you can try. This explanation is similar, so that we can go to the next question. Is it okay?
Yes, ma'am.
Okay, so let us go to the next question. The next question is also like number of cycles of length 4 in S6. You just say which all structures we have to take. Cycle of length 4 in S6. Yes, you can use that formula also. Yes, you can use that formula also. Otherwise, means which structure you have, which partition you have to consider. Okay, for cycle of, yes.
Ma'am, how it comes 2 factorial and 1 factorial, ma'am?
Which one?
Ma'am, here, this sum itself, ma'am, solution.
Okay, solution. Here, here actually we need cycle of length 4 in S6. So in S6, that means we have to consider 4 plus 1 plus 1 structure. So there is only one cycle of length 4 and there are 2 cycles of length 1. So we have a formula that, no, 6 factorial means n factorial by 1 power alpha 1, 2 power alpha 2, etc. like alpha 1 factorial, like that. So here we are considering 4 plus 1 plus 1. So the formula will be 6 factorial divided by 1 square into means 2 cycles of length 1 into 4 power 1 into 2 factorial into 1 factorial. Which all powers are there, like 1 power 2 and 4 power 1. So we have to take the factorial, 2 factorial, 1 factorial.
Okay, thank you.
Okay.
Ma'am?
Ma'am,
here why not consider 4 plus 2?
Okay, 4 plus 2. 4 plus,
Yes.
we need the cycles of length 4. 4 plus 2 is not a cycle. It is the product of, it can be the product of disjoint cycles, but it is not a cycle, because I hope that you got it. It is not a cycle, no?
Ma'am, 4 plus 2, like 4, LCM of 4 and 2 is 4. 4.
Yes. But we need the cycles. It is the
Cycle.
product of disjoint cycle.
Okay. Yes, ma'am. Okay.
Okay. So, okay. So I hope that you got it. If any you have any doubt, you can ask. Otherwise, we can go to the other concept.
Yes, ma'am.
Okay. So here, this is a question from IIT JAM 2024. Which one of the following groups has elements of order 1, 2, 3, 4, 5, but doesn't have an element of order greater than or equal to 6? You can try. Okay. Let us see. So let us see the explanation. So here they are saying which one of the following groups has elements. So which one of the following groups has elements of order 1, 2, 3, 4, 5, but doesn't have an element of order greater than or equal to 6? Okay, so if you are taking S6, S6 has an element of order 6. If you are taking the cycle 1, 2, 3, 4, 5, 6, then this has an order 6. And so option C can be eliminated. We don't know about whether it has element 1, 2, 3, 4, 5, but it has an element of order 6. So we are eliminating option C, S6. Then coming to the option D, take the permutation. If we are taking the structure like 3 plus 2, then it will have the order 6. So 1, 2, 3, 4, 5, then it will have an order 6. So we don't know about the other order elements, but 6 order element is there. So we can discard option D also. So option C, option D is discarded. Is it clear that option C and D can be discarded?
Yes, ma'am.
Okay. So now the question is, what about option A and B? So here I have given a method to, I don't know whether any other method is there. For me, I feel like this. Just analyze Sn using. So if you are getting the questions like this, just analyze Sn using the decomposition. Like we are taking the partitions of sig n, like 6, 5 plus 1, 4 plus 2, 4 plus 1 plus 1, all that listings. Take the partition and check the order of each element, and then decide whether it is even or odd. And a permutation is even or odd. We have the definition according to whether it can be expressed as the product of even number of transpositions or the product of odd number of transpositions respectively. And we know that a cycle of odd order means a cycle of odd cycle will be even permutation. Like that concept is also there, no? So using that concept, we can design a table like this. I don't know whether there is any simple method, but this is also a method to analyze such questions. So just check 6. So order 6 is there, and it is an even order. So means even cycle. So even cycle is an odd permutation. And if you are taking 5 plus 1, so the order is 5, and this is an even permutation, because here this is an odd cycle, so it is an even permutation. If you are taking 4 plus 2, then it has order 4, and this is an even cycle, so this is an odd permutation. This is also an odd permutation, so odd into odd, it is an even permutation. If you are taking 4 plus 1, it has order 4, and here it is a means even cycle, so this is an odd permutation. Here if we are taking 3 plus 3, then it is order is 3. And this is an even permutation. Sorry, this is an odd cycle, so it is an even permutation, and this is also an even permutation. So when we are taking the product, then we will get even. So likewise, we can form this table. So just analyze what we need. We need to find the order of elements of order 1, 2, 3, 4, 5, but it shouldn't have any element of order 6. So we are considering A6, not S6. We need A6, means even permutation. We have to check whether there is an even permutation of order 1, 2, 3, 4, 5. So first check one order. Obviously it is an even permutation, so 1 we are done. What about 2? Here 3 options are there, means 3 type of permutations are there of order 2, but we need even. We need to consider A6. So here it is odd, but here it is even. If you are taking 2 plus 2 plus 1 plus 1, then it is an even permutation of order 2. That means it is an element of A6. Okay, so we got an element of order 2 also in A6. Now we need 3. Here we got a 3. If we are taking the structure 3 plus 1 plus 1 plus 1, then we are getting an even permutation of order 3. Now we need, what about 4? So if you are taking 4, then also if you are taking 4 plus 2 structure, then it is an even permutation of order 4. If you are taking 5 plus 1 structure, then also it is an even permutation of order 5. But if you are checking 6, 2 options are there. Either it is 6 or 3 plus 2 plus 1. In both the cases, it is odd. That means it is not in A6. So what we got? We got in A6, we got elements of order 1, 2, 3, 4, 5. But we don't have an element of order 6. So we are done. So what we got? So A6 is correct. So this is which one of the following? This is an MCQ question. So A is correct. And if you are, another method is that you can just find the elements of particular order in like in A6, you just find out the order 1, 2, 3, 4, 5. So like that also you can do. I don't know whether there is any simple method. Do you know any simple methods? Then you can say. Is it clear, this method?
Yes, ma'am. Yes.
Okay. So, so we get option A is correct. I think some has given option B in the comment section. So option A is the correct answer. If you have any doubt, you can ask. Otherwise, we can go to the next question. So let us move to the next question. So this is a question based on the homomorphism. How many group homomorphisms are there from Z2 to S5? This is a question from IIT JAM 2023. You can try. This homomorphism concept is important for GATE exams and as well as CSIR NET exams also. Okay, some has given the answers 26. Okay, good. Let others also try. We'll wait for 1 minute. Okay, so let us discuss the question. So let us recall the first isomorphism theorem. Let phi from G to G dash be a homomorphism with kernel K, and let gamma K from G to G by K, it is a quotient group G by K, be the canonical homomorphism. Then there is a unique isomorphism mu from G by K to phi of G, such that phi of X is equal to mu of gamma K of X for each X belongs to J. So whenever we are getting this homomorphism questions, first try to first let us check what are the normal subgroups of Z2, because kernel of this homomorphism is a normal subgroup. Okay, so kernel of a homomorphism must be normal subgroup. So first let us analyze what are the normal subgroups of the domain. So here, when first consider the normal subgroups of Z2. So normal subgroups of Z2 are identity and Z2. So now consider how many homomorphisms are there with kernel as E and with kernel as Z2. Okay, so the number of homomorphism with kernel 5 is equal to 5 as Z2 is equal to 1, because if you are taking kernel as Z2, then Z2 by Z2 is isomorphic to identity. So there is only one homomorphism is possible. So it will be 1. Okay, now the next one is the number of homomorphism with kernel 5 is 5 as identity. That means Z2 by E is isomorphic to Z2. That means we have to find the number of subgroups in S5 which are isomorphic to Z2. Okay, so that is that number of subgroups of S5 of order 2 we have to find. That is simply means what? We have to find the number of elements of S5 of order 2. So again, we are using that concept of S5. We need to consider the structures 2 plus 1 plus 1 plus 1 and 2 plus 2 plus 1. So the number of permutation in S5 of the structure 2 plus 2 plus 1 is equal to, using that formula, 5 factorial by 2 power 2 into 1 factorial. Sorry, 1 power 1 into 2 factorial into 1 factorial. So we will get 15 structures. If we are taking the permutation of the structure 2 plus 1 plus 1 plus 1, then we are getting 5 factorial divided by 2 power 1 into 1 power 3 into 1 factorial into 3 factorial. So we will get 10. Hence, there are 15 plus 10, 25 permutation in S5 of order 2. So we got, there are the number of homomorphism with kernel 5 as E is 25. Now the total will be 25 plus 1, so 26 is the answer. So many have answered correct in the comment box. I hope that answer is clear. If you have any doubt, you can ask.
Ma'am?
Huh? Yes.
Ma'am, if I take reverse, like Z2 to S5.
Z2 to S5 to Z2. Z2.
Yes, ma'am. S5 to Z2,
Okay.
yes.
Okay. Huh. Then, which are the
Then
normal
how?
subgroups of S5?
Yes, ma'am. So how many homomorphism? Two is right or not?
Okay, let us. What are the normal subgroups of S5?
Identity A5 or
Huh.
S5.
Yes, only 3 are there. So, is there any homomorphism possible with kernel as identity?
No, ma'am.
No, it's not possible. So, what about A5?
Yes, ma'am. Yes, ma'am.
Yes. How many are possible?
1.
1. 1 is possible.
Yes, ma'am.
And what about kernel as S5?
Yes, ma'am.
Also 1.
Yes, 1. So, total 2 is the answer. Is it clear?
Yes, ma'am. Yes. Okay.
Okay. So let us move to the next question. Here also the number of group homomorphism from the group is Z4 to the group S3. You can try.
Four.
4.
Yes,
Yes.
ma'am. Four.
4. Yes, good. So 4 is the answer. Normal subgroups will be normal subgroups are 0, 0, 2 and Z4. With Z4 as kernel, then only 1 we will get, and as identity, then we have to consider the number of cyclic subgroups of S3 of order 4, but there are no elements in S3 of order 4, so it will be 0. Now, number of homomorphism with kernel is equal to 0 to, we have to find the number of elements of S3 of order 2. So, we just have to find the number of permutation of the structure 2 plus 1. And hence, we are just adding that 3 plus 1, it is equal to 4. So similar question is this, you can try yourself. You can take the screenshot. You can try and verify the answer. This is a question from GATE 2024. And as I have mentioned earlier, there is at least one question from permutation and homomorphism. So you should be very clear about this concept. So you can take the screenshot of this question and verify that the answer is 16. So let us try this question. It is a question from CSIR Net June 2023. This is an MSQ question. So we have to analyze each and every option. Okay. Any other answer? Okay, so let me start explaining. So we have two groups, G1 and G2, and we have a surjective group homomorphism, G1 to G2. If G1 is cyclic, then G2 is cyclic. We have to analyze each and every option. So first, let us try option 1. If G1 is cyclic, then G2 is cyclic. Is it true? What we need for a cyclic group? We need a generator, right?
Yes, ma'am.
Yes. So G1 is cyclic, it is given. So G1 is cyclic means there is a generator for G1. That means A is let's suppose A is a generator of G1. Then just verify that phi of A is a generator of G2 also, because we can means we are claiming that phi of A is a generator of G2. How can we
Yes, ma'am.
say? Yes, we can say that,
Because
no?
yes, ma'am. Because phi is a surjective map.
Yes, phi is a surjective map. If it is not surjective, then is it true? If that surjective condition is
No, ma'am. If it is not onto or surjective, then it is not true.
okay. Okay. So others can also verify that. We can also. Do you have any counter example? Means, can you give some counter example? Okay, you can just check any counter example. So let us move to the option 2. If G1 is abelian, then G2 is abelian. Is it true? We can just verify using the properties, like if we are taking A dash B dash from G1, which means since it is surjective, we can find A, B in G such that phi of A is equal to A dash and phi of B is equal to B dash. And so A dash B dash, we are just using the properties of phi, and hence we are getting that A dash B dash will be equal to B dash A dash, and hence G1 is abelian. So likewise, like just using what we need, if we are taking option 3, what we have to prove? We have to prove that phi of H is a subgroup. So what we have to prove? We have to prove if we are taking any elements of phi of H, it should if we are operating that, then also it should be there. So just use that properties and just use the property that it is surjective homomorphism, and then you can find that option 3 is also true. And option 4 is also true. Okay, you can just use that concept of normal subgroups and you can prove that. And now another task for you is that you just remove that condition surjective, and then just verify which all statements will be true. If it is not true, then have a counter example for that. This is a task for you. You can just try. Just remove the condition of surjective and just try and just analyze all other options. Okay, so in this case, if it is a surjective group homomorphism, then all the options are correct. Okay. So you can try this. And this is also a question for you. You can try. Here we are just using the properties of homomorphism, and the first homomorphism also we can use, like what we can use is that, like kernel must be a normal subgroup, and that order of the groups and all that you can use, and you can solve this question also. This is also giving as a task for you. Okay, so you can take the screenshot. This is a question from CSIR net December 2023. This is an MSQ question, so you have to analyze each and every option. So here you just verify the answer is 1, 2, 3, 4. Okay. So here are some references that I have used while preparing for group theory questions in competitive exams. There are many results in group theory. So means while preparing for competitive exams and all, we have to be consistent. We have to practice a lot of questions and all. and we have to be careful of each and every options. Like the mistakes that I'm saying is from my experience. Like I have did some mistakes, especially in part C. I have analyzed, means some options I selected and it was wrong because of my calculations and all. So I'm saying from my experience that be careful while attempting MSQ questions and all. So you can use these references. Means some results I have taken from these books, and so if you want proofs of that results, you can refer these books. And hence, believe in hard work, and all the best for all the aspirants. Do your best. Thank you. If you have any doubts, you can ask.
So participants are requested to unmute yourself and share the feedback. Yeah. Yeah, Praveen, Dharmendra is.
Yeah, I am Dharmendra Singh. Good morning, sir. Good morning, ma'am. This survey was very nice and very explanative. I joined lately because of some issue. Thank you very much.
Okay.
Thank you for the feedback.
Okay, yes, Praveen.
Yes, good morning, sir. Good morning, ma'am. I am Praveen Mishra. Yes, ma'am. It's a nice session, ma'am. Good collection of problems are very good, ma'am.
So,
Thank
Praveen,
you.
Thank you.
Praveen, could you
Yes,
introduce
sir.
yourself?
Yes, sir. I am Praveen Mishra from Madhya Pradesh.
Okay.
I have done my master's from VNIT Nagpur in 2022. Yes.
Okay. What is your current status?
Yes, sir. Preparing for CSIR NET examination.
Okay, all the very best, Praveen.
Thank you, sir.
All
Thank
the
you,
best.
ma'am. Thank you.
Others?
Hi, ma'am.
Good morning.
Yes,
Hi.
Hi, ma'am. Refi
yes.
here. That was really a very interesting session. And thanks for the valuable inputs from your side. That was from the very, everyone will think like group theory is very basic area. There's nothing much more to learn. But your class was beyond expectation. Okay. I really recognized how much weak I was in the basic content. And your tricks was very easy to follow. Thank you for that. And ma'am, I have a doubt, but the question was little lengthy. Can I read it out? Or do you want me to share
Okay,
the screen and ask it out? If time
I will.
permits, may I?
Okay, sir, is it okay?
Revati, I think you can message me that doubt in WhatsApp. That will be more
Okay.
better.
Okay, sir. Thank you.
I will forward it to Ardra. Okay.
Okay, thank you.
Okay, thank you, Revati. Others, Gopika.
Good morning, sir. My name is Gopika Senil. I'm from St. Thomas College, Thrissur. I'm a final year BSc Mathematics student. I'm preparing for IIT JAM examination this year. Your class was very useful, ma'am. You covered all the important topics. There were questions from all the sections. I loved your choice of questions, and that too, it was previous year questions. So it was very useful. Thank you, ma'am, for the class.
Okay,
Welcome.
Yeah, thank you, Gopika. Okay, others? Aishwarya? Yes, Aishwarya.
Good morning, sir. Good morning, ma'am. My name is Aishwarya. I am studying in PSMO College, Tirur. I am currently doing my third year in BSc, and I'm preparing for IIT JAM. The session was really helpful, and you covered. I got to know my weak spots, and you gave us a lot of tricks and a bit of theory, and I really liked it. Thank you for this session, ma'am.
Welcome.
Thank you,
Thank
Aishwarya.
you for the feedback.
Any others? Okay. So, thank you, Ardra, for this nice session. You have finished all the problems in the time itself. Very well planned and well organized. session. So I really appreciate your dedication for doing this class. And the session is also really good with a lot of interactions. I think I have seen that many of the participants are responding to your questions.
Yes, sir. Yes.
So I hope that you will engage more such sessions in our platform whenever time permits. And I take this opportunity to wish you all the best for your research and academic career.
Thank you, sir.
Once again, thank you, Ardra, and thank you, everyone, and all the very best to all the participants. Bye.
Thank you, sir, for this opportunity.